What's up, guys? My name is Michael and welcome to my YouTube channel. Today we're going to talk about C++ algorithms and data structures. And this is the first day of doing this tutorial series on C++ algorithms and data structures, and that's what we're going to do right now. We're going to do C++ algorithms and data structures. And you know what? I believe that we could do this in 14 days. You might think I'm crazy, but I actually believe that we could do this. Now, you might not become an expert on C++ algorithms and data structures, but you'll at least become a decent person at it. You'll become decent at this, and you'll be very good at it. Well, better than the average Joe, at least. Okay, so so today we're gonna have a huge review of C++. So right now, we're just gonna do Chapter 1 C++ Primer. Okay, so let's just review the basic blocks of C++. So here we're gonna talk about how algorithms in C++ work. So first of all, the thing is that in to write algorithms and data structures, you have to have the basics of C++. So we're going to go over the basics of C++. So let's just go over this. The simplest C++ program is actually just a main that lets you return ones or zero. Not one or two. It's literally this. Okay, it's just not this one. Where is it? Oh, it's right here. Okay, so the most simplest program in C++, well, this is not the most simplest one, is this. It's not the most simplest one. In fact, just get rid of the cout and cin here and just have int main and then return 0. That's all it is. Okay, so let's just talk about this. We have hashtag include Iostream, and what this does is it's the input Iostream just inputs code from Iostream that lets you use the library, lets you use the libraries and every other stuff. So by convention, main function returns 0 to indicate success, and returns non-zero if it means failure. So the std lib library defines constant exit success to be 0, and the return statement of line 10 to return 0 with successful information. Okay, so when you output things in C++ is you use cout, and then we have these brackets here, and what these brackets mean is that it's an output operator that pretty much just supplies the output stream to the standard console. That's what it is. std is not needed here because we using namespace std. Using namespace std means that we're just going to use code in std so that we don't have to declare std over and over again for every single part of every code that we need. std stands for the objects are from the system standard library, and we include the prefix when referring to objects from the standard library. So it is possible to inform the compiler that we wish to use objects from the standard library and make this we using. Okay, so that's what it is. Cout is to print something out. Cin is to get something from the console, data from the console. So here we have the that's what it is. We have cout enter two numbers, and cin it pretty much just gets the integers, the numbers from the keyboard, and then it stores them into x and y. Okay, so here // means a comment, and /n means a new line when you print out something. So if you do /n after this, you could actually print out a new line like this. Okay, next thing, let's talk about types. Okay, so to talk about types, what are types? They're basically the language's basic data types, and these are like the most basic fundamental things you could use in C++, like just out of ordinary, very basic. It's the most basic data type you could use. That's what fundamental types are. So what are they? Boolean, char, short, int, long, float, double. Okay, Boolean is just a true or false value. Char is a character. Short is a short integer. It can't hold that much space as an integer. It's just short. Int is a regular integer. Long integer could hold more integer values. More. When I say more can hold more, I mean like decimal values, decimal places. It could not decimal places. Long integer, it could hold like very, very long numbers. So like it could hold like there's like a maximum. I don't know off the top of my head, but it could hold a lot of numbers. Float is a single precision floating point number, and that is just it could hold decimal numbers. And double is it's the same thing as a float, except it could store way more precision numbers, way more decimal numbers. That's what it means. Like after you do 3.141516, it could do way more, holding more digits of pi. I don't know how much max is, but that's what it is. So character holds a single character, but a character in C++ is normally 8 bits, but the exact number of bits used for char variable is dependent on the implementation. And yeah, this is just a character is. And such as is tailored to generate code for the CR and create efficiency. Okay. So by allowing different implementations to find the different basic types, C++ can tailor its general code and achieve maximum efficiency. Literal is a constant which appears in a program. These are just regular characters, very regular character literals that you could use like A, B, C, D, E, F, G, like the alphabet and other stuff. But they also have these codes of literals that let you print out a new line, /n, /b, // quote, // / t, tab, /0, null. Null just means like zero, whatever. But not zero, it's like null. / double quote lets you print out double quotes. When I say these, this is when you print out to the screen using cout. You could use these characters. You could use these literals. Integer is just an integer and it's a number. So terms short and long into terms short integer and long integer. Decimal places numbers such as 0, 25, 98765, and -3 are type int, and the suffix IRL L can be added to indicate a long integer. That's not I. My bad. It's L. As in this is a long integer. Okay. The octal base 8 constant, so I specified by prefix a number with the 0 digit. And hexadecimal base 16 constants can be specified by prefixing the number with O/X. So that's like if you wanted different base numbers, then you could use OX and like stuff like that. So when you declare a variable, the option to provide a definition or initial value. If no definition is given, the initial value is unpredictable. So it's garbage. If you don't give like if you don't assign a value to it, it's garbage. So like this /octal number / shared new line long int short. Yeah, that's what it is. So variable names, you could do anything, a combination of letters, digits, or underscores, but the first character cannot be a digit. That's it. So it could be anything, letters, digits, or underscores, but first character can't be a digit. And so yeah, these are all valid variable names. So although it's illegal to start a variable name with an underscore, avoid it because they use it to identify their own. The C++ compiler uses it to identify their own internal identifiers. So yeah, C++ doesn't specify number of bits in each type, but short is a 16-bit, long is a 32-bit. There's no requirement. Long could be strictly longer than a short, but it can't be shorter. And type T is returns the size of T, which is expressed as some number of multiples of the size char. For example, given a type T, the express size of just returns the how long it is. So if you have on a numerical systems, like if you char is 8 bits, right? If you do size of a char, it might get 8 bits. If you do 8 bits long, and the size of int is 32 bits long, hence size of int is 4 because because it's 32 bits long, it's 4 bytes. I think that's how it works. I don't know. You can search that up. Enumerations. These are just they hold a set of discrete values. Common use in enumerations provide meaningful names to a set of related values. Each element had an enumeration is assigned with a single integer value, and by default these are counts up from 0 to whatever number it is. So here we have enumeration day: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. By default, it will just start from 0. Assign 0 as Sunday. Monday would be assigned 1. Tuesday would be 2. Wednesday is 3. Thursday is 4. Friday is 5. Saturday is 6. What does that mean is that when I use day, whatever day I want to use, like day sun, that day Sunday, or that Sunday would automatically have the value 0. Okay, that's what it means. And enumeration mood. If you declare the enumeration whatever value you want to have, that's what happened. It would just override what the 0 to whatever number it was. So happy would have they had happy set equal 3, sad equal 1, anxious 4, sleepy is 2. So when they do day equals Thursday, so day is Thursday. So what is that? 0, 1, 2, 3, 4. So it would have the value 4, and then my mode is sleepy. What is that? Well, sleepy is 2. So my mode has an integer value 2. Since we don't specify values, the specific values, Sunday would have 0 and 1, and it will keep going like that. Okay. Let's move on. Float point is just a decimal number. It gives you the exact. It leaves, if you don't initialize it, it's garbage. You don't know what it is. So that's what float points is, decimals. So you could, to force the literal to be a float, just add an f. When I mean that, like if you want to force number 2 to become a float, just do 2.0 to be f, or 1.234 e negative 3 f. You could use capital as f or lowercase. It doesn't matter. Floats are just float or double. They're just decimal places. They're just decimal numbers. That's what they are. Okay, so we're gonna go over pointers, arrays, and structures. A pointer is just a memory address, a location in the computer's memory. Pointer is the variable that holds the value of an address given a pointer type t. The type t star denotes a pointer to a variable of type t. When I say type t, that means anything. Okay, so for example, int pointer denotes a pointer to an integer. And two essential operations are used to manipulate pointers. The first returns the address of an object in memory, and the second returns the contents given at the address. So in C++, the first test is by the address of an operator. So that's the ampersand. That's the address of the operator. So if x is an integer variable in your program, ampersand x is the address of x in memory. And accessing the data that the address is referring to is called dereferencing. This is done using the star operator. So for example, if we were to declare q to be a pointer to an integer star, so and then set integer star q is equal to address x, we assign the x's value with star q, and assigning an integer variable to star q effectively changes the value of x. So here they have an example here. Okay, char ch is equal to q char pointer, char star, which is a pointer, p equal to the address of ch. So that means this is a memory address of ch. So if you dereference, if you set the data that p is pointing to using star to have the value x, that changes this value of ch. So they did star p, which dereferences the pointer where it's pointing to. That changes the value to have the x. That actually changes it. Here, I'll just show you a diagram in Paint quickly. Very quickly. Okay, so here they have a... So what do I mean by dereferencing? So if I do, let's say ch, right, is a character, and it has the value q in memory, right? So what do? They created a pointer named p. I'm just talking to these two lines, right? Pointer p points to the memory address of this. So this has a memory address. All right. Actually, maybe I shouldn't do it like that. I'll do it like this. Okay. Take this out. Okay. So this is a memory address. It could be anything, like 1, 2, whatever. It's an address. So p points to this. So the data I'm changing at p, at this memory address, I'm going to change it to x. So that changes this q into x. So ch, the value of ch gets changed. Okay, I hope you guys understand that. Okay, so that's what it means here. Here they print out c out, so the data that the pointer is pointing to is going to print out q, and ch. If you change the value of ch, well, yeah, that just changes the character value. Print out the data that star p is pointing out, dereference star p. We already talked about that, and they print out ch. Okay, so you should see pointers are very useful to data structures where objects are linked to one another. Pointers need not to be pointed only to fundamental types such as char and int. They may also point to complex types and even to functions. Indeed, the primary of C++ stands in front of the ability to handle low-level entities like pointers. So it is useful to have a pointer variable that points to nothing, and that is a null pointer. So a null pointer is basically just assigned a value 0. An attempt to dereference null pointer gives you a problem because it's not pointing to anything. It's just 0. So changing the value of what points 0 to nothing to something else doesn't make any sense. So that's a runtime error. So all C++ implementation define a special symbol null, which is equal to 0. This definition is activated by inserting the the hashtag include, see this library in front of the beginning of file, so it allows you to use the symbol null to mean 0 if you include this library. So void is also used to means no type at all. You could declare a variable to be type void. Well, you can't declare a variable to be type void. You could declare a pointer to be a type void. What I mean by that is that the pointer could basically point to anything. That's what it is. But you have to cast it. So such a pointer can point to a variable of any type. Since the compilers are unable to check the correctness of such references, the use of the void pointer is strongly discouraged, except in unusual cases where direct access to computer's memory is needed. So when you declare a pointer on the same line, you could do this. You can't. You can't do this. You can't do this. If you do int star x, y, and z, that actually just sets the pointer of x to have that value, and then it creates integer variables. So you can't really do that. All right, let's quickly go over arrays. Arrays are just a collection of elements of the same type. So giving any type, it starts at the value 0 and the index 0, and it goes up to the size of the array minus 1. Okay, so here they have created a double of f array called f, and it holds 5 doubles. That's what it means. The size of 5, right? And it's indexed from the starting of 0 to 4. And they created an array of type m to have 10 values, and it holds an array of 10 ints. And then here, when they declared f at 4 equals to 2.5, because the last element at this double is f of 4, setting it to 2.5 changes the last element of this to become 2.5. And then when they said m at 2 is equal to 4, that changes this to the value at 012 is equal to 4. And then when they print out f at m number 2, that'll print out f. Okay, m at 2 is 4, so then you want f at 4. F at 4 is 2.5, so that prints out 2.5. It's not possible to increase the number of elements in an array, by the way. After you declare it, you have to literally create a new array and then reassign every value to it. That if you want more space for an array, so that's the problem about arrays. C++ has a vector type, which has more capabilities than array type, and it actually allows you to change stuff. But yeah, we'll talk about that later. You could also create two-dimensional arrays of arrays. So here, like int a15 to 30 declares to have 30 objects, each of which an array of 15 integers. So that's what it does. Okay, you could also assign the initial values of an array. You could do that by have whatever type it is, and then it would set all their values to declare them of what you want them to be. So it's also possible to create an array of integers as to create an array of pointers. So yeah, pointers and arrays. There's a connection between pointers and arrays in C++. Inherited from the C language, the name of an array is equivalent to a pointer of an array of the initial type. So if I do create an array of C of cat, and I set a pointer to equal to C, that creates a pointer to the first value in the array. And yeah, that's what it means. If you create a char pointer and then you set the address of C at 0, which is that's just C0, points at 0, C0. And if you declare them all, it'll just at C2, P2, Q2, it prints out T. Because here, I'll show you why. So they declared a array called C that has values. Sorry for my drawing. CAT. And then set P points to whatever C is pointing to. This is a pointer. C, you could declare pointer to arrays in C programming, because arrays are also pointers. So P points to the first value of, when you set P equals to C, that points to the first value of C. And then if you set Q is equal to the memory address at 0, well, what is the memory address at 0? Well, the C at 0 is C, right? Because of the first, it's indexed from 0, 1, 2. 0, let's begin with index 0, 1, 2. 2. Okay. C is pointing to at C0, so if you set Q is equal to the memory address at C0, that's what it does. Q points to that. And then when you declare them C2, well, Arrays are pointers are also arrays. Arrays are all pointers. So at index 2, what is P's index 2? 0, 1, 2, it's T. What's Q's index 2? 0, 1, 2, T. What is C's index 2? Well, that's just array. 0, 1, 2, that's T also. So that's what happens. The equivalent of array names pointers can be confusing, but it helps explain that C++ parent mysteries. For example, if you're given two arrays C and D, comparing them does not test the contents of the two arrays are equal, rather compares the addresses of their initial elements, which is probably not what the programmer would have in mind. So if you compare C and D, this pointer to this pointer, it actually compares the memory addresses. So that's not what you want. Well, at least not what most programmers want. Like if you have like a separate D array named D and you call it dog, right? If you want to compare these and you use equals equals, that just compares the first the memory address. That's what it is. So it's idea is better to use a vector class. We'll talk about that later. All right, string literals. That's just hello world. It basically is characters that lead up to null string. Character strings represent this as C-style strings. They are inherited from C. Unfortunately, this representation does not provide many operations. So here, string is just an array of characters. That's what it is. So in order to distinguish like C++, they have a better string type called standard in the STL. So we call these STL strings. In order to use STL strings, it is necessary to use the header file hashtag include string. And since STL strings are part of the standard namespace, their full name is std : string. By adding the statement using std : string, we inform the compiler that we want to address this directly, so we don't need std : What I mean by that, if we include std : string, yeah, we don't have to do std : string every single time, like if we're using this in the beginning. So yeah, that's what it is. String is just their STL strings allows you to add strings together, stuff like that. It also allows you to use greater than or less than. There are also other operations. It's true that to be greater is greater than this. To be is greater than not to be. To be is greater than not to be. It's not, I don't think it's checking the length. Yeah. Okay, so you can see what the greatest and sign means online. You can search that up. Here they create a string John. Is the size of, what is the size? 1, 2, 3, 4. There's four characters. Have C point to char C is going to have the value at the third character, which is 0, 1, 2, 3 is n, and then you add S plus equals Smith. Well, that's just John Smith. Okay, so that's not that hard. C style structures. Good way to aggregate elements like an array. They're just different types. A structure can be different types. Each member of field is a structure given by a name, and we consider that like this. Okay, so enum meal type. Well, this is gonna have 0, 1, 2, 3. So no preference is 0, regular is 1, low fat is 2, vegetarian is 3. Struct passenger. Well, passenger string. You could include many different types in a struct. So you could have a string. Meal type, type, hey, meal preference, boolean, which is true, false, and string for no fly zone. So this, if you want to declare a new struct, you would just do passenger, pass, and equals to that. John Smith, vegetarian, true, and then that. Okay, individual members of these struct can be accessed using member selection operator, which has the form of struct name.member. So if you want to access each method members, you use dot. Like if I want to get the name and meal type, I use dot and to get them. Okay, so if you set a struct equal to each other, it copies all the values of P1 to P2. This is actually a deep copy. Well, we could call it a deep copy. It actually copies every value. Unless it's a pointer, it just copies a pointer address. Pointers, dynamic memory, new. So we often find useful in data structures to create objects dynamically as a need to addresses. The C++ runtime reserves a large block of memory called free storage, which is called the heap. The operator new dynamically allocates the correct amount of storage for each object given from the free store and returns a pointer to this object. So yeah, new allows you to do that. So C++ allows for pointer variables to be any type, even to pointers accessing in an array. So here we have, yeah. Let's say you create a passenger, a pointer to a passenger object. You use new passenger. That allocates memory. That's for how much a passenger is. So if we wanted to create a new instance of the new operator, let P be a pointer to a P structure. This implies P is an actual structure, and then you could do that, yeah. Using star P meal dot. To access each one, you have to use each field. You have to use the arrow, which is a hyphen and then a greater than sign. Each structure for pointers, at least. Pointer name is equivalent to dereferencing this dot point member. That's what I mean. The pointer name, if you want to access each individual members inside the struct, you have to use the arrow operator, or you could use this, because this is a pointer to a struct. So you have to do that. Okay, let's quickly do it. Delete operator can delete objects that are being allocated through new. It just deletes it. It's like, unlike garbage collection in C++ and Java, this just deletes all the dynamically allocated objects. Arrays can also be created with new. The system allocator returns a pointer to the first element of the array. So here we have a pointer to a char, and then they created 500. Well, that creates a pointer to 500 values. Let's just show you what that means. It's just like an array. That's exactly like an array, actually. Actually, it basically, it pretty much is an array, because they have a pointer buffer. I'm not drawing this correctly. Buffer, right? And they're pointing it to 500 characters. That's what they're doing. And they said the third character have a delete. Memory leaks, that means you failure to delete dynamically allocated objects cause a memory leak. That's what it means. So every time you have a new, you should have a delete, okay? References just means a way to refer from one object to another. It just provides an alias. So string author equals this, Samuel Clemens. When you do a reference, pen name equals author, you're referring to this string. It's just another name for it. This is useful if you want to don't want to modify. Well, if you want to modify something else for it, so unlike pointers, which could be null, a reference in C++ must refer to an actual variable. It can't be null. Okay. Once initialized, it stays like that. Okay. When a reference is declared, the value must be initialized, and it must be treated as an access to the underlying object. I think you could change references. Wait. I don't know. You could try that yourself. Scope. Constant means you can't change it. Can't change its value. Constant. Cutoff. That just means you can't change the way the literals are used. So here, constant indicates that the value cannot be changed. So constant may be virtually anywhere the literal might be used. So this, I'm guessing you can't change any of these values here. I never used this. You should use const though. Const, you can't change the value of this, of n days. Constant, you can't change the value of this at all into number in hours. Okay, so yeah. Oh, type def is just another way to refer to something. So in addition to creating names of constant, is also used to associate a name with a type. This association can be done with a type def declaration. Rather than declaring a variable, a type def defines a new type name. So this just means okay, every time I define buffer pointer, it is a pointer to a character. It's an alias for another name of this char pointer. So every time when I do buffer pointer, it just means char pointer. Every time I see coordinate, it just means a type of double. That's what it means. Global scope. Yeah, okay, so when you declare statements, they have to be in, if you declare them in a block, it's only accessible in the block. They are local to the block. So if a variable is global, that means it could be seen everywhere. And to not do that, you just put it outside. You can put a variable outside of the block, and it should be declared global. Two variables of the same name may be defined within nested blocks. When that happens, the variable inner block remains active. Okay, so Here they have int cat equals to 1, which is constant, so you can't change it. This means it's global. It could be accessed anywhere in this program. So now they redeclared it int cat equals to 2. This is local to main, so whenever we refer to this cat, we're actually referring to whatever's inside the block. And when we print out cat, that's what happens. So yeah, that's what it means by global. So after this block is over, int dog goes equal to cat, that actually refers to the global cat, which is the global variable, because this local variable is gone. It's gone. So when we talk about cat, we're referring to the global one. I don't want to make this video way too long than it should be. Namespace is just a mechanism that allows a group of related names to be defined in one place. This helps organize global objects into natural groups and minimizes the problems of globals. So if you declare a namespace like that, my globals, it contains two variables, cat and dog, of this my globals. The namespace may generally contain definitions of more than complex objects, such as types, functions. So you could access the object in a namespace by using the group, : it's called fully qualified name. Okay, so for example, my globals cat refers to the copy of variable cat in my globals namespace. So it's just a way to help you group names together in one place. You might have already seen the example of namespace. Many of the standard system objects, such as stout, are namespaces. Alright guys, now we're going to talk about expressions. Okay, so you could... let's just quickly go over this. Okay, you have arithmetic operators, which is plus, minus, multiplication, division, and modulus. Modulus means taking a remainder. You could also have unary, plus, and minus. What that means is it's just, you could change it to positive or negative. That's what it means. Okay, let's keep going down. This video is way too long. Okay, post increment means that you add it after whatever statement it is, add by 1. Pre-increment means you add it before the statement. And then post-decrement is the same thing. Add it after the statement. Pre-decrement is added before. So if you do 2, int I equals to 2, then you do int j equals to I plus plus. J is going to equal to 2, then I gets added afterwards. So I is going to be 3. Okay, int k is equal to minus 1. I is going to, not minus 1, minus I. I is going to get subtracted by 1, and then k is going to equal to that. So I is going to equal to, so I equals to 2, right? So now you add 1, so I is 3, right? I minus 1, so I is now equal to 2, and k is going to equal to 2. And then post increment is, k is going to add by, no, okay, a is going to, the value at a is going to, you're going to print out the value at a of k, which is a of 2, which is 2, right? And then k is going to get added by 1, so that's going to be 3. Okay, so we have relational operators. This is just less than, greater than sign, less than or equal, greater than equal, not equal. So that it just makes true and false statements. You have not expression. Whatever, you could put a not in front of everything. That changes the thing to not. So if it's true, it becomes false. False, it becomes true. Okay. Then and means it's, if they're both true, it's true. If they're both false, if one of them is false, it's false. And if, I went back too far. So if they're both true, it's true. If one of them is false, it's false. And if they're both false, it's false. That's what and is. Okay? If the left-hand side. Logic or, if one of them is true, it's still true. So if you have true, false, it's true. False, true, it's true. If they're both true, it's still true. If they're both false, it's false. Okay? That's what logical or is. Okay, so we're going to keep going down. Yeah. Sometimes if you just do this, it just checks if it's not null, I think. For example, the following could test whether the pointer p is non-null before accessing it. And then it would result in an error. The execution will stop if the first condition is not satisfied. Okay. Bitwise complement. It basically shifts all the, switches all the ones to become zeros and the zeros to become ones, I think. Bitwise and, it's just what I told you before. So in C++, their numbers for in binary, which is 1 and zeros, right? So and is the same thing as the before. If they're both true, it's true. If one of them is false, so true as in, but they're both 1, 1. If one of them is false, they're both false, which is 0. And if they're both false, it's still false. Okay. Exclusive OR, the same thing. Oh no, exclusive OR is different. If they're both true, it's false. It's the same thing as an OR. OR is the same as I showed you before. Before. Shift left by 2 bits. Shift right. That just switches the bits right and left. I can show you that later. Actually, I won't show you that. You just check out my series of what it is. Here, I'll just quickly show you guys. So if it's like 1, 0, 1, and 0, 1. If you shift right here, it's going to, like, by 2, it's these are going to get crossed out, so then it's going to be 1, 0, like these are out, and then it's 0, 0. Shift right. Yeah, I think, yeah, that's what it is. Okay, shift left, this is the other way. Alright, arithmetic assignment operators. Okay, so minus equals, times equals, plus equals. That means I is equal to I minus 4. J is equal to J times -2. S is equal to S plus this. So you're this thing. Okay, so assignment operators just adds them. It's the same thing as you assign them to whatever the thing is, multiplied by the thing. Okay, so there's other operators. : class name, member, class scope resolution, namespace, member, namespace resolution. This is it's a ternary operator. So it evaluates this expression. If the expression is true, the value is going to be this. If the expression is false, the value would be this. So here we have, it checks if it's smaller. If x is less than y, the value of smaller is going to be assigned to x. If x is greater than y, the value of x is going to be, the value of smaller is going to be assigned to y. So yeah. Streaming, input and output, we saw that. Okay, there's something called operator overloading. These are operators that are not really intrinsic a part of C++, but you could change what the meaning of the operator is. So you could change what the plus means. So if I create like a fraction class, right, which a class is just a group of things, right, it changes in I could add 2 fractions together. That will change what the add means. I could write stuff that changes it. Precedence means the order which they shows without parentheses. So here, namespace member goes first, then it's the subscript, function subscript calls, postfixed, prefixed, dereferencing, multiplication, division, add, subtract, shift, comparison, equality, bitwise and, bitwise or, logical and, logical or, conditional, assignment. Okay, you could change values through casting. So if you trying to change this value, into cat equals 14, I want to change the value of 14 to be a double, so now I could have the decimal places of it. I could cast it, just put parentheses, make it double. Another thing you could do, functional cast, which is change double and just put parentheses. Both are legal, but some prefer the functional cast. Yeah, casting can have different things. This evaluates, so if I do 18 divided by 16, I said double division 1 is equal to that. 18 divided by 16, well, that's going to evaluate it first, and it goes in by 1s, right? Because they're both integers, it's an integer, and then it changes to a double. So it has 1. If you change it to double for both of them, well, it's going to give you the double, and you set the double equals that. Yeah, if you cast it afterwards, it's the same thing as the front part. You could have explicit casting. Double to int is more dangerous because the fractional part is lost. Casting from a double to char is even more dangerous because, you know, the pointer, they have different meaning. Okay, so they also have classes called static cast, dynamic cast, const cast, reinterpret cast, and we'll discuss static cast here. Static cast. Static cast is used when a conversion is made between 2 related types. For example, 2 numbers or pointers to pointers. Okay, its syntax is like this. So you have a static cast and then the expression. The most common is conversion between numeric types. Some of these conversions may involve a lot of loss of information. For example, a conversion from a double to an int. This conversion is done by truncating the fraction part, not rounding. So here, yeah, it's the same thing as the other one. Static cast changes the double to become an int, and then to be, yeah, the double to become an int has a value 3. Oh, this actually rounded. No, it didn't. It truncated. This type of cast is more verbose than C-style and functional cast shown earlier, but this is appropriate because it serves a visible warning to the programmer that many unsafe operations taking place. In our examples, we use functional cast for safe casts, and these newer cast operators for all other casts. Some older C++ compilers may not support the newer cast operators, but then the traditional C-style and functional cast may be used instead. Okay, so it's also explicit cast. Okay, you could the compiler automatically inserts a cast into the machine-generated code, so it allows you to do that. You lose information. So int I equals 3, int d equals a 4.8, and double d3 equals I over d. This is going to get you, d3 is going to equal 0.628 because, and if you set, because, well, it's a double, integer divided by double is a double, so that's what happened. And when you then he set it, assign it to a double d3, that's what happened. Int I3 is equal to d3, I3 is equal to 0, and then int d3 is equal to 0. Okay, so this assignment may lose information. So general rules, play it safe. If the compiler's behavior regarding the implicit casting of a certain value is uncertain, you gotta do it. Okay, if, else, if, else. Just remember to put brackets, guys. So if snowmail is less than something, else if, check it. Okay, you guys should know, this is just a review. Switch statements. Okay, so whatever switch this happens, then you have cases. It's just a long if statement. Remember to put break because then it would immediately go to default, and then it won't go to default. It would go to line by line. So if there's no break, it would insert, edit, insert, and it would do edit, delete. Just remember to put break. Do while loops. These aren't that bad. While this statement is true, it's gonna keep going. Loop through here. Just remember about while loops and do while loops. Once this statement becomes false, like let's say inside the code in the first statement, it's still going to run until the next iteration. Just remember that. So like let's say I becomes 101 right here. It doesn't break in the beginning. It's going to keep running the code and then it's going to go back up and then it'll check and then it break out. That's what it does. For loop. Remember, for initialization, condition, increment, like that. Yeah. What else? Break and continue. Once this happens, we break. Okay. That breaks out of the loop. That's what break is. Continue means it goes back up to this starting condition and then it checks it if it is. So then it doesn't go through the thing. Okay, let's talk about functions. Functions allows you to do things. You could have return type void, means there's no return value. Function name, you have argument list and function body. Okay, so you have a function name, boolean, even sum. You have the arguments here, and then you have the function body, which is this. So this sums up all the things, and returns true if sum is even, sum is odd. Okay, expression in the return statement. Oh my god. Okay, I'm making this way too long. Okay. Expressions in the return. Okay, so you could return. This just returns a type. Okay. Exit success means return 1. Let's just keep going down. Argument passing. You could pass by reference. You could pass by value. Pass by reference means that you're referring to whatever that was inserted here in this case. So let's say I have int cat equals 1, int dog is equal to 5. So if I pass in cat and dog, and in this function I change the value of dog, the reference, when I pass by reference means the dog, after this function, this value that was passed in for reference, for dog, so dog was passed in as the reference, right, by pass by reference. After this function, the value of dog will be changed. Okay? So dog becomes 6 because they added 1 for the reference. Because passing by reference means that I'm going to refer to this dog when I make changes. I don't pass in a copy. I'm going to refer to this dog. When I pass this dog into this function, I'm just going to refer to it. So whatever I do here, it's going to affect the dog after the function. Passing by value means that I make a copy of it. So I have cat equals to 1 here, right? I make a copy of cat, which is 1, and then I add 1 to 2. but it affects that copy. It doesn't actually affect the original value. So yeah, its output is still stayed by 1. Let's keep going. Constant references as arguments. Yeah, you could pass in constants. It's illegal to change the value of this when you pass it in. That's what constants are. Array arguments, you could pass arrays in. So, what about arrays? Well, when you pass an array by value, it results in making a copy of the entire array. The answer is no. When the array is passed into a function, it is converted to a pointer to its initial element. That is, the object t becomes a pointer to t. So that's an assignment to an array element of an array within a function does not modify the actual array contents. In short, arrays are not passed by values. Arrays actually are passed by reference. So yeah, it does actually affect it. The same call is not meaningful to pass an array back as a result. The function call essentially in an attempt to do so will only pass a pointer to the array's initial element. If returning an array is our goal, then we should either explicitly return a pointer or return a pointer of a type vector. Okay. Function overloading. It just means you have the same name of the same function except with different parameters or different arguments. What does it mean by parameters? So you have print, you have integer x. Well, this time they have a passenger, so when they do print, this is function overloading. So that's what it is. Remember, the return types don't matter. Really matters is different arguments. So if they have the same arguments and the same name, that's illegal, even though they have different return types. Here, okay, operator overloading. So you could change you can change what the meaning of equal means. So here they change the meaning of equal. So normally it means equal means it checks if it has the same memory address. Well, they overloaded it, so now equal, something like that. Okay, so now when they check equal, it's useful. It checks if the passengers are actually equal. Okay, inline functions is just a way to, return. Not return. Inline functions are a way to make it more efficient. You probably don't need it. Okay, class in C++ is fundamental C++ provides a way to define a new user-defined type associated with functions and operators by restricting access to a certain class member. It is possible to separate out the properties that are essential to a class's correct use for it. So here, class counter just means that, okay, I create an object of counter. It's a blueprint for, it's basically a blueprint for whenever I want to create objects. Okay, so class counter, it's now a blueprint that could create multiple counter objects. So counter, you could have methods and functions, increase by, stuff like that. Private means you can't access it by you can't access the end count for other people. Other people can't access it because entities cannot be accessed by user of the class. Constructors, their way to initialize your variables, your instance variables right here. Constructors' jobs initialize the values of the class's member variables. It's common for as a getter function. Okay. You could also get and set, create methods of that. An important feature of classes is access control members may be declared to be public. Access outside of the class or private. They will access within the class. Okay, yeah, let's just keep going. Member functions. Jesus, okay. Yeah, these are just functions you could have. So in passenger, you could have functions of is, frequent, flyer, const. You could have other stuff, make, frequent, flyer. You could have any kind of function you want, okay? Class yeah. Const means, okay, so const indicates that the member function is an accessor. This informs the user of this class that you will not change the object's contents. So that's what, make sure you make a const. Okay, so when a member function is defined outside the class body, it is necessary to specify which class it belongs to, which is done by preceding the function name with the scoping specified class name. So yeah, if it's outside of the class body, you have to Show which class it belongs to when you're writing the implementation for each object. Here, let's keep going. Okay, so you call the in class. Whoa, inline functions. That means that you just, I don't know. It's a better way. It makes it more efficient. That's what it for the compiler. Nowadays, compilers are pretty good, so it doesn't even matter. Constructors and destructors. Constructor special member function performs an initialization. It causes the thing to initialize the variables and makes it come into existence. A destructor is called when a class goes out of existence. So here, so normally it's given a default constructor if you don't have any initialization information. The second constructor is given the values of the member variables to initialize. Third constructor is given a passage reference to copy information. Okay, so here, copy constructor basically just means you could copy the class to passenger and make another copy of it. That's what it means. Copy the if you have two passengers objects, right, and you want to copy all the contents of one into another, you use a copy constructor. Okay, this constructor is just to initialize all the variables and the instance variables. Oh yeah, default constructor, you could initialize it to whatever. Default arguments can be assigned to any legal value. Okay, so yeah, copy constructor. They assign all the values to the reference of this, so they don't change it. They also made a const so they explicitly don't change the contents of it. Yeah. Calling a default constructors, you do that. Calling the second constructor to initialize all the values, you do that. Calling the another constructor that they had, you do that. This is how you call the copy constructor if they're both passengers already. This is how you assign it. You could copy values by using equal because it actually copies all the things over. Yeah. You could also use initialization lists. It's like this. You just initialize the name like that. Not initialize the name. Initialize all the instance variables like that. Okay. Destructors is a way deallocate memory. So here, for destructor, you just put a tilde and you free the allocated memory. So, yeah. So we're not strictly to provide our own destructor, but if you allocated memory, you have to write destructor. Like if you don't, you get a memory leak. Memory allocation. Yeah. This means vector size of 100. Initialize B from a danger. Ooh, this is danger. Okay. Yeah. If you set B equal to A, that copies everything of B and A from a danger. Okay. You could have possible memory leaks. Default action is called a shallow copy. Invokes the constructor with the argument value and allocates 10 elements on the free store, but we have not provided an assignment operator. The statement does a shallow copy. Only pointers are copied, not array contents. Worse yet, we have lost the pointer to C's original 10 element array, thus creating a memory leak. So, if you want to make a deep copy, this is a shallow copy because it doesn't copy the arrays, it copies the pointers. Yeah, it only copies the pointers. They didn't have a copy constructor, so it simply copies each member of A into B. It sets B.data as notice this does not copy the contents of the array, rather it copies the pointer to the array's initial element. This is called a shallow copy. That's what it does. Let's go down. Just allocates a new array, copies everything over. This is called a deep copy. They made a copy constructor. Make sure you do copy constructors because that makes a deep copy. Then they overloaded the equals to make it sure that it's definitely a deep copy. Yeah. If it's not equal to the assignment, they free it, then they reassign, deletes the old array, create, initialize a new array size, create a new array, copy all elements over. Then they return this. Okay, yeah. Friend just means you could access all the private instance variables. The class may access the function may access the class's private data. It allows you to do many things here. Let's just keep going. Oh, you could have classes and nested classes within each other. Yeah, you could have a bookmark. Okay. Stl Library Vector. Yeah, vector class means these are all the things in the Stl library. We'll go over them later. But yeah, it provides a template so that users could use different types of data types. So here you could have a vector of int, char, and passenger. That means you could have a vector is just a better way to use a array because it allows you to change the size. Okay. Yeah. These are the functions for STL strings: substring, find, insert, erase, delete, get line. You guys could look this up. It's not that hard to read. So in C++ you have source files, CPP. Yeah, that's just, source files. You also have header files, which you have all the implementation, the definition of the function, and then you have the source file that tells you the implementation of the functions. So here, the example program, they have the credit card class. This is in the header file. They use this to avoid repeated expansion. So here they have it in the header file, right? And then after that, they needed to implement the, So here, they have the header file, right? Which is all the definitions of this, all the functions and stuff. But then, oh, my computer's about to die. They have another implementation file, which they use to actually implement all the functions. So that's what in C++ they do. Yeah. And then they have a main file, which they use to test it. Yeah. Not that bad. Let's just keep going. There's their credit card class. So remember, when you design responsibilities, independence, behaviors, everything is, or think of it when you define, excuse me, make sure you define all these behaviors or class, your behaviors of the independence, behavior for each class to be independent for other classes as positive, and responsibilities divide into actors and stuff. Pseudocode, you can write pseudocode. UML diagrams. Keep in mind, guys, this is just a review of C++. Okay, we're gonna go to exercises after this. So I'm gonna go to do exercises, and we'll see what's gonna happen now.